Alright. Hi everyone, thanks for being here on Sunday in the morning. It was hard for me too. So I'm here to talk about computation modeling today. It's interesting. I think it's a pretty different topic than you guys have probably heard being here. It's a little bit more abstract and different types of concepts, but it relates to IT a lot. And I'm an analyst. What I do, I'm doing IT stuff a lot of the time. So anyway, I'll dive into the details and you guys will start to see. All right, so like I said, I'm an analyst, and I've done modeling in a lot of different scenarios, and it's becoming a more and more important skill and tool that's being used. I have experience in the financial world, in bioengineering, and in internet marketing. Directly, where I've done modeling, and like I said, it really intermeshes with IT a lot. So as I go through some examples, you guys will start to see that. So first, I kind of want to just begin with a broad overview of what models are and kind of how they work as I see them. First case would be like statistical models, where you're taking one dependent variable and a number of other variables, and you're trying to use those other variables to describe a dependent variable. And you're generally doing it based on data that you have, large data sets, small data sets, whatever it may be. And then the converse would be a theoretical model, where you have an underlying intuition and you understand how things work, and it's giving you outputs that are based on that relationships that you understand. And I divide them pretty narrowly, but in the real world, there's a lot of overlap between the two. So I'll go into a couple examples. So here's one example that I thought was somewhat insightful. If you were just running off a statistical model, you'd look at some data like this, which is home prices over the past couple years, or 15 years. You might see something like price. You see how price is upward trending, and you could make the assumption that it's going to continue to move up if you only looked at it from a statistical point of view. In having a bit more of a theoretical point of view, you could look at something like price per income and say, eventually things are going to bottom out. It can't really continue in that trajectory because people can only afford such a house price given their income. So, this was just a simple example I thought of that, you could use just to see where theoretical models are, give you some intuition when a statistical model can actually fail. So it's just good to understand that. And then I have another example. Okay, and then this is something where they kind of wind up being the same thing. So here we're looking at carbon dioxide concentration and temperature. You're looking at all these data points. These are, you're obviously reading the amount of carbon dioxide and the temperature, and you can see there's an upward trend. It's pretty obvious. So, it's not too hard to see. And I mean, so in this case, your theoretical understanding and your statistical understanding coincide. So this is a case where they kind of are one and the same, or they turn out to be one and the same. So anyway, like I said, that was just a kind of a brief overview. So I'm going to go through a couple more in-depth examples with things that I've dealt with. And at any point, if you guys have any questions, or something looks strange, or I'm moving a little too quickly, let me know. I'm here to teach this to you guys too. So one place where I've worked is in computational finance. An obvious one is portfolio theory, where basically you have a set of securities that your firm owns, however much money they manage, whatever, however you divide it up, whether it's by account or particular investment strategy that they're using. And they generally make a purchase of a set of securities, and you're looking to optimize for return and minimize risk for whoever you're investing for. So this is just a huge information problem to be able to process this information and really see how things are working. So like I said at the bottom here, it requires sophisticated information capability. You're constantly collecting new data, and you have people who need to quickly react to the markets. So there's a lot of different components here. It's getting the data, it's having models that interpret it, and different things. So, and as we all know today, things are changing pretty quickly. So here is a graph of kind of what I was talking about. This is obviously an ideal case, but just to give you a kind of a visual insight. So this grayish, greenish area there is your set of investment opportunities. So that would be all the securities you have available to you, and you're going to make some decision on how much, what securities you're actually buying and the amount of risk and return that you're looking to actually get in your investment strategy. So, you need to have good information capability to be able to find that and to actually, make that decision. And most of these numbers are based on historical data, obviously. So when you're looking at, let's say, 20 different securities, whether they're bonds or stocks, you're going to be looking at kind of how they've reacted historically. So that's how a lot of these numbers are come up with. I don't want to go into too much detail there, but I mean, you're coming up with a number like standard deviation, which approximates risk. You're saying the return of this security over a 2-year period, how much has it changed, things like that. So these things are very useful, but all with a grain of salt, of course. Another place where it's used is risk analysis. So that would be, looking at, based on the securities that you currently own, if things completely tanked, I mean, how bad could things get? That's like what I've called stress testing here. So, it gives you a way to quantify risk, to actually understand how much money you could possibly lose, right, in worst case scenarios, which, people are always trying to do. It's hard to do accurately. Different securities have different numbers that are very important. So in the stock market world, obviously the S&P 500 is important for fixed income like bonds and corporate bonds and other securities like that. Interest rates are very important. So you're looking at different things in different places, but the general idea is the same. So you'll have some type of model in this case, which is basically going to take a number of inputs and give you, a value for whatever your security is or group of securities. It could input any number of things. Up here I have, unemployment, GDP growth, wage growth, inflation, interest rate, exchange rates. I mean, it could be anything really. And then you're going to want to look at how these, if these values go up or down, how is it going to affect the value of your securities or your group of securities? And by looking at a lot of these extreme cases, which would be, for most of these where things are on the down. So, for instance, if unemployment rises, you're going to have the value of your securities could be hurt depending on what they are. Or a good example would be interest rates. Interest rates and bond prices move opposite. So you'd look at, when interest rates come down or when interest rates go up, how is that going to affect your prices? So, these are important things, and people make pretty big decisions based on what these models say. So, important. And like I said, I'm trying to tie it back to all you guys here, which is that it's a big, big information management problem. Traders need to be able to collect data, react to it, react very quickly. So it's a big deal, very large business intelligence problem, and will continue to be. So it's definitely something there. So now I'm going to move on to my next example, which is bioinformatics. Do you have any questions on the previous one, though, I guess, before I... Yeah.
in security risk management right now, the number that I'm constantly asked for and I basically have to make up is how likely is something to be exploited? Is this something that could be put into a model in any way and given some, I don't know, some sort of reasonable analysis of, or is this going to continue to be a made-up number? Because honestly, in my opinion, it depends on the hacker as how likely, something that's obscure and difficult to exploit can be exploited by somebody who's properly motivated. I don't know. I'm wondering if this could help me.
Yeah, I would say anything I gave would be more hocus pocus than reality, right? I mean, that's a very, very hard thing to judge whether something could be. I mean, I've heard things across the board, so hard to say. It's hard to say. That's a tough question. I mean, if I could answer that, right, I'd probably. Right, exactly. Well, I don't know about that, but just something. All right. So anyway, another area that I've done modeling in is bioinformatics, which there's a lot of similarities between actually the modeling that's done in bioinformatics and the financial, computational finance. So I thought this was a logical step. So in any case, what you're doing here is you're modeling biological systems. What I have most experience with is looking at computer simulations of cellular subsystems, and you're really honing in on a particular subsystem and trying to understand how it works. This could include, metabolism, where you're having metabolites and enzymes that interact. It could be signal transduction pathways, which would be, hormones and things like that, and then gene regulation. I mean, it's a huge, huge world, and it's really a lot of different ways to look at biological systems. I'll get into some detail. So here I'm talking about exactly what you want to look at. So I've seen in a lot of cases, there's a lot of people who just look directly at DNA when they're building a biological model, and they try to understand gene expression and how that relates to protein production and how those proteins interact in your body. Some people have taken simplified approaches where they actually look directly at proteins and they try to understand how proteins interact, how they create enzymes, and how it understands metabolism and how that is used to understand metabolism. But it's a tough problem, and it's really balancing complexity with accuracy. I mean, obviously it's more correct to look directly at DNA. That's actually what the problem is. That's where things start. But these are huge problems. So simplifying the problem and looking at different aspects and isolating the problem is really a big deal with bioinformatics. So just a little bit of an overview there. So this is just one pretty good picture that I saw that kind of show you just the complexity of the problem. You have just tons of interactions happening all over the place. This particular example is, I can see apoptosis there and gene regulation. So, you're talking about, how gene regulation affects cell proliferation, how, apoptosis is when a cell is basically told to kill itself and, die. And so, you have just a huge amount of things going on here. You have external factors, which are these ones. So this kind of shows what I was talking about. You're looking at a subsystem. You treat things like these hormones and these growth factors and different things as external factors, and you really isolate what's happening in your particular subsystem. So, but I don't want to get into too much detail here. Just, it's a good picture to just kind of give you a rough idea what these problems are. And then the next step would be to go to something like this, where you have actually a set of differential equations that describe each of these interactions. So, ultimately, each of these arrows is a chemical equation. It's got a certain, rate constant defined with it. There's certain numeric parameters that govern each one, and you can build something like this theoretically in every single case. It's really just figuring out where you want to do it and how you want to do it. So, like I said here, and here there's also, so here are literally the chemical equations that are described, and you have concentrations of each different chemical changing over time, and you can really drill down and look at the numbers and start to understand what you're looking at. And then you'll have an objective function, which is at the top here, where you're actually looking at what your body's trying to obtain. So here it's a minimize, but I mean it could be something like the cell is you're trying to maximize the amount of glucose in the cell, or really anything. And one place where I've seen this used a lot is where they're using bacteria to manufacture chemicals and proteins, which I talk about a little bit more in the next slide. So that's called bioprocess engineering. So for instance, manufacturing insulin, which diabetics need, industrial chemicals like ethanol, that's a big one. But I mean, being able to do all this requires huge amounts of computing resources. It's really unbelievable how complex these problems can get. And there's large dollar amounts associated with all these problems. I mean, a lot of companies can have huge savings, especially if they're making insulin on very large levels, or ethanol, or whatever it may be. So it's definitely a new and upcoming thing that's going to continue to develop, I think. So I think that's my last slide for this one, right? So do we have any questions on any of this? I know that's a lot to look at in probably a small amount of time.
Okay, so this is sort of a comment as a follow-on to the last question. But looking at your statistical gathering, one place I see that this could be useful in our space, in IT security in particular, that is for DLP, or data loss prevention. And the first step in data loss prevention is all about information management and understanding where your data is in your environment. And too often you have different pieces of intellectual property or other sensitive documents floating around in who knows where. And so by using what you're talking about to tag appropriate fingerprint points, if you will, aside from obvious things like scanning documents for something that says confidential, but more subtle things, you can probably identify what systems are being used today that you had no idea that are critical to business, and you can't just turn them off, but they need to have a higher level of protection put around them. You might not have been aware of before. So using your statistical analysis, you can gather a couple data points of like, okay, if it has this, 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 and this, kind of like IDS fingerprinting too, right? Then you might better cost justify spending money to secure systems, or minimize or mitigate some risk that you didn't need by getting business groups back onto where they should be.
Really leaning on what Don was talking about, with all of this statistical analysis, don't we have a ton of unknowns though? I mean, looking at his stuff, he's got so much historical data, and then he's got all of this discrete math that he can do on all of this historical data. There really isn't a lot of variation. There really isn't a lot of unknowns. Whereas I kind of feel like in our situation, even with DLP, there is a ton of unknowns. So I'm curious. I would love to see something like this. I'm just kind of curious.
Okay, so the only reason there are not knowns in this case, in the context of DLP, is because we haven't done the work to identify the fingerprint points. And what I'm talking about is to use prediction to try to get appropriate positives, identify appropriate data points, and then use that as justification for spending. But because that's what he was really talking about. But as far as the talk, this is really, to your point, is about looking at the past and using it to predict the future and what might happen. So I think that what we need to do is look outside our organizations and look across industry to statistics for like Gartner or whatever. Like when there's a breach, they cost this much money. And when we could take vulnerability assessment tools that we use today, and they all rate threat, vulnerability, criticality based on complexity, ease of exploitation, and then you add into good threat modeling practice, you have to do an information assurance audit on yourself. If you don't know how to do it, find somebody who does because you want it done right. But it's all about valuing your assets and your whether it's data or systems or both, and then you can combine the threat and the impact based on your valuation. Couple it with predictive analysis. You can feed that into, okay, well, there's going to be a likelihood of vulnerability. I can predict that because of my security posture. I mean, we'd have to really work this out to make it a nice, smooth presentation, right? But I think that there's something we could do here, which is to take the math of it, because it all comes down to a rating of like 1 to 5, right? We've all seen this stuff. And then you could put some math behind, well, how likely is it that we could get exploited? And then with the IA, Information Assurance Audit, how much is that going to hurt us? And that all goes into justifying budgets or making some decisions about where to mitigate our risk. That's what I think.
One area where I have to do capacity planning from time to time is in network, designing networks and servers, and how much bandwidth you need, how many CPUs you need. And I was wondering what tools you use for that. If there's are good resources on the net for, say, doing an analysis of variance within OpenOffice Calc. Maybe using sheets, extra sheets for extra dimensions, that kind of stuff.
I think the tools I've seen used are pretty across the board. I mean, obviously, spreadsheets and Excel and OpenOffice are the biggest ones, especially in finance. But that I almost see that a little bit as a limitation. I mean, I think they really could be doing a lot more, using more sophisticated tools and things like that. The things you guys know of. Does that answer your question a little bit, or? Right.
How easy are they to learn? Right.
Well, exactly. That's the.
Just my opinion. I think the statistics model is going to help in not necessarily predicting future security breaches, but what it can do is baseline what you have. You can gather statistics on your network servers. And get a baseline, and based on that statistics, you can start looking at something that goes out of the ordinary,
right, look for outliers.
And then start looking for things like that. I think there's automated software that will do that, stuff that gathers like NetFlow data, and then you start zooming in on specific things and see peaks and things like that. But those are, I believe, they're statistics-based. Right, and developing point systems and things like that, and threshold values, and I guess really looking at your historical data in that context and being able to identify outliers and things that are abnormal, anomalies, things like that. So anyway, is that it for that one, or any more questions? No? All right, I'm going to continue to this next one that I'm going to talk about is internet marketing, which is the same basic theme, looking at consumer behavior, historical data, and trying to predict what they're going to do next. So in any internet marketing situation, you're going to have a database with transactions, and it's really just grouping the transactional data to see what consumer preferences are. And obviously this needs a huge amount of business intelligence software, being able to use data cubes and things like that. So I mean, especially in this context, you have a particular audience, and it's understanding what that audience is and what they want to see based on performance you've seen. So the first place to start, of course, is organizing your audience. Ways I've seen it done is just by specific qualities, like where they live, how old they are, gender, things like that.
You could also be doing other things like looking at mouse movements, clicks, what purchases you've actually seen them perform, documenting interests. These are just examples that I have thought of, but I mean, there's a lot of ways that it's done, and I'm sure other ways to do it. And really, it becomes being able to store this information succinctly and being able to access it quickly and use it the way you want to use it. So the next step is, of course, organizing your advertising. So you've organized your audience. You understand, you've grouped them in different ways. You understand certain qualities about them. Now you need to look into organizing the ads you want to show them. So there's a lot of different ways to do this. The simple way would be just assigning categories to advertising, tracking trends. If you see that males from a particular demographic like a particular certain type of ad, I mean, you document that. It's all about just finding these correlations and these relationships and understanding them.
I think there's a lot of good crossover there too. Most of us, we don't tend to care for marketing people or technical people. But at the same time, if you think about it, a lot of that stuff regarding like your demographics and everything, it has a computer security equivalent that you could be taking the exact same thing, such as, from net flow diagrams, we know where the attacks are coming from. We can see where attacks come from, where they go to, types of attacks, browser-based attacks, DOS attacks, things like that. And I think a lot of this advertising stuff and a bit of irony could actually translate over well to information security in terms of predicting not necessarily predicting, but seeing what's happened before and then maybe using that to give us some advanced knowledge of where to go in the future. So I think there's actually some good crossover there.
Really? Well, it makes sense. I mean, it's all these are all similar problems, right?
Yeah, and that's the thing. And when you think in demographics, from an advertising perspective, you're thinking, age range, gender, where they live, and you could replace that with things that we're looking to predict.
Right, where are they?
Yeah, exactly. Where are the attacks coming from? Who's getting hit? That kind of thing. So I think you could actually take a lot of this advertising modeling and concepts and actually use them in information assurance.
That's good, definitely. All right, and so taking kind of those big ideas and then actually breaking it down into something that works. So step one I see as like a decision tree like I have here. Just taking some simple number like age, grouping each age group, and then looking to break it down to decisions. So, I mean, this is assuming, right, that you actually have this kind of data on your users and that you actually have relatively good categorization of the ads you're looking to post. And, you can start to make sense of a situation. You could look at, this is actually a lot of detail here. I don't want to get into too much detail, but basically you would use decision trees in a way that would allow you to see, okay, if I was just showing this particular advertising to this group, how would it have done? If I just showed this advertising to this particular group, how would it do? Or, so you look at your past experience and you try to hone in on where things make sense. And decision trees are a very powerful tool you can use there. I don't want to get into too much detail there because it's very easy to. But I think the picture kind of shows you pretty well. All right, so that actually was the last one I have there. I don't know, any questions on this this particular idea? All right, so last one, of course, was internet security, which I probably have less experience than all the other ones that I spoke about, so I decided to use kind of a simple example that seemed intuitive to me. A little bit of a different twist on what you guys were talking about. In this case, online casinos. So most of the time, I think when you talk about internet security, you're thinking of external threats, like what you're saying. With online casinos, they have a lot of problems that are actually internal, which is, they're actual users gaming their system. So a couple examples of that are like chip dumping, where people are using online casinos to transport money across country lines. It's player collusion. That's a pretty obvious one where a couple people gang up on one or two other people in a room and they collude and use their knowledge to win, things like that. And then there's also foreign exchange. They have a lot of foreign exchange problems because online casinos operate across country lines. They're very susceptible to foreign exchange fraud. So I kind of just went through some simple ways, simple logic that you could implement to prevent these kind of things. Just simple rules, nothing too complex here. So in this case, player collusion, very simple. You see two IP addresses in the same room for more than a week, twice in a single week. There's something wrong. You need to probably flag those users or take whatever preventive measures you need to in that case. Right. That's a that's a simple way to break it, right? So you'd have to think of a way to account for that. I'm not sure how you deal with that, actually. Good point. All right. Then another example, right? Chip dumping. So the rules I came up here were just pretty simple. It's just you set a transactional limit. You don't allow over a certain amount to be moved between countries, and you have to manually approve the process. I'm sure there's probably simple ways to break that too, but right. So this is actually I think a larger problem in Eastern Europe. A lot of these online casinos are basically being used to transport money across country lines. So we both go into a room and I just continually lose to you, and I'm money laundering. Yeah, that's basically what it would be. So these are things that the online casinos can't they can't be letting that happen. That's a big breach of their security, so they have to take preventive means and measures to prevent it. And then of course foreign exchange fraud's a pretty simple one. This is just taking simple measures to update your exchange rates and things like that. If a user is able to figure out that the way you're implementing exchange rates is ineffective, they can easily start gaming you and making money just off converting currencies through your online casino. So these are all sound like pretty simple things, but they have very large ramifications for these guys doing business. So it's just in keeping with the overall theme that I've been hitting. That's using past data and trying to prevent problems or predict purchases and things like that. So tried to touch on this a little bit. Okay, so in conclusion, modeling is becoming important. It's important in a lot of places, as we have all heard. And it all depends on computation, being able to implement, manage data, and find trends with business development and things like that. So in summary, I don't know if anyone has any questions on this last example other than what I've heard.
If we're interested in exploring this, could you recommend some software? There are lots of things out there. SPSS is pretty famous. There are some open source equivalents, but that's pretty complex. You could ratchet down a level to like SQL Server analysis services. Do you have a good place to start for somebody who wants to explore this?
I've used SQL Server. It's pretty powerful, but it's also pretty expensive too. But it's very powerful. You can do a lot, and it's relatively easy to learn. What I've been using lately a lot is Pentaho, which I've actually liked a lot. That's open source. It's cheap. Took me a little while to figure out a lot of quirks. You can get stopped up on something real simple, and there's not a lot of documentation out there. But I would recommend that very highly. SQL Server, if you have the budget to do something like that, that's great too. That works well. But there's a lot of tools out there. But yeah, Pentaho I think is great. You can download it, start messing around with it. They have a couple different applications. I use their data integration software a lot. You have data sitting across a lot of different databases. It's a real easy way to just kind of pull it all together and shoot it out in an Excel format. You can start looking at it, sending it to other people, automating it on emails. It's real easy to figure out. Does that answer your question a little bit? Or?
How do you spell that?
Pentaho?
Yeah.
P-E-N-T-A-H-O. Right. I don't know if there are any other open source business intelligence software like that. There's a bunch of others. Talend is one. Okay, so a lot of good stuff out there. I think it's just getting the documentation and figuring out how to use it is the biggest hurdle. But I think if you hammer it out, it can be done.
Hi, I have a few questions. One regarding the tools aspect. You mentioned Pentaho and Excel. Are you using other kind of programming languages to help model? Or it sounds really manual what the process you're doing. You're getting a bunch of people give you logs, you import them into Pentaho and then export to Excel?
Yeah, it is pretty manual currently. More because you need to actually be in touch with the data, and you actually have to really get a feel for things before you can start automating things. But I think you're right. I think eventually you have to move to automate things and get away from a manual process. But depending on what you're doing, the manual process is important for the first couple steps. And as you start to really understand what the outliers in your data are or what the trends you're trying to find, I think then you move to automation. I see that as like a second step. And you got to be real careful just about automating these kind of things because there's a big impact on all these things. So
okay.
Does that answer your question?
Yeah, it does. Great. And the second question I have is clarification with respect to internal versus external threats. I read that your external threats are just people doing random port scans and brute force attacks, and insider threat is actually somebody abusing the application itself. Like in your example of online casinos, users actually logged in and abusing the system, the application itself, and not insider threat as in an employee within the organization.
Oh, that's true. Yeah. That is generally how that term is used. Okay. Yeah, point taken.
All right, great. Thanks. Okay.
Anybody else?
Good. All right. Thanks for listening.